All right, so this week we'll be doing as much review as we want. Before we do that, though, let's talk about the format of the final. It's basically going to be the same as the midterm. It'll be held on Tuesday for this class. It'll be held on Tuesday, December 14th. That's the day of the officially scheduled final exam time. There is a 2-hour block somewhere in there. I forget what it was. That is, scheduled for this. Of course, we will not be showing up in person. It will be asynchronous because you will have 24 hours in which to do it. First of all, it's 7.5% of your final grade. It's 75 points. Remember that we are online, so if you have any questions, you can go ahead and post to Piazza or to YouTube. I'm looking at both of them. Anyway, you'll have 24 hours. The handout will open up on Canvas at 1 second after midnight on the 14th. The web hand-in will be open at that time, and you'll be able to hand it in, grade it, hand it in again, refine it as much as you want up until 1 second before midnight on the same day. All of that is Central Standard or Central Daylight Time, whatever we're on right now. Again, you'll have 24 hours to do this. It's a design for that it should take you no more than 2 hours to do it. But if you want to take an extended amount of time, if you want to do it in the morning, come back to it in the afternoon, whatever you want to do, that's fine with me. Just do not collaborate with anybody else in the classroom, outside the classroom, or anything like that. I don't want a repeat of the midterm. It'll consist of coding activities. In fact, you already know one of those activities because I already announced it on Piazza a while ago. It is cumulative in that it will require all the skills that you've developed throughout the entire course: loops, file I/O, searching, sorting, all the way up to and including everything that we covered up until searching and sorting, including that. Starter code may be provided, in which case you'll have to follow a link. Of course, this requires you a computer to do all this, of course. No collaboration or outside help is allowed. You saw how easy it was to catch folks with Moss and then to map that back to websites and then get DCMA, takedown requests, et cetera, big, huge fiasco and headache for me. And don't do it. All right, let's not have that again. We'll be available for questions on Piazza if you have them. Of course, make sure that you're not posting any code in your posts. Make sure that, of course, the level of help that we're going to give you is not as much as we would give you on a hack or a lab. We're not going to walk you through anything, or walk you through running GDB or something like that. There is a final exam bonus, as hinted last week, for filling out the student course evaluation. As of right now, 70 of the 190 that are still enrolled have filled that out. The bonus is based on the response rate. Not all 190 of them are going to sit the final, I'm sure. However many do sit the final, though, I take that response rate, however many fill it out, because it is anonymous. I'm not going to be able to award points like the other surveys. Whatever the response rate is, times 10 points, everybody gets that. So already we're up to whatever 70 divided by 190 times 10 points is. That's the minimum that you're going to get. Of course, if more people fill it out, the higher the bonus. If the more people that don't show up for the final, the higher the bonus. But you get up to 10%, which translates to 1% of your grade. So if you're on the bubble, you should be encouraging your peers to fill that out. And don't just fill it out to fill it out. Again, I do take these things seriously. So be constructive in your criticism. If you've got suggestions for changes or modifications for the future, please do so. It has affected the content and the approach of this course in the past. I can tell you about improvements and adjustments that have been made. So anyway, that's any questions on the format. Otherwise, this is posted to Piazza and you'll be able to read it all there too. Okay. So review. Again, we have advent of code, we can do that. I just took the final here from a few years ago. I guess this is 9, 10, 11, 3 years ago now. This is the final that was, now it was for the H section, don't worry, the main section just had to do, it's the same exercise but in C here. I don't know anything about Pokemon. I've never played Pokemon or anything like that, but I did like this as a good exercise because It involves all the skills and all the data processing skills and programming that you've done this entire semester. It doesn't require you to know how to play Pokemon either. Basically, you've got this list of Pokemon. There are 151 different Pokemon, apparently. And we provide that data for you in the CSV file. And it has the following format. It has an ID, the Pokemon's name as a string, obviously, and its type. Its type can be one of, I think, 18 different values. There are ice Pokemon, there are psychic Pokemon, there are fighting Pokemon, right? And when one Pokemon type fights another Pokemon type, apparently there is this multiplier. So for example, when ice tries to fight fire, then they're half as effective as they normally would be, right? When a normal tries to fight a fighting Pokemon, it's just as effective as it would have been with any other Pokemon 1 times, right? And there's some, let's see, let's take a look at the data here since we have it available. It's all stored over here. This is not a CSV file. This is a space delimited file. Can we find something that is, okay, so when water fights rock, it's twice as effective. So there are various multipliers here. There's 0, there's 1/2, there's 1, and then there's 2, I think, right? That's all codified in this big giant grid here. I took that grid and I put it into a CSV file and a space delimited file, so that the objective here is that, let me go back to the handout here, is that when somebody runs this from the command line, they will, here, this one, they will provide the name of a Pokemon that fights the name of another Pokemon, and then we have to look up their type and see that Jinx is of type Ice, and when they attack this Flareon, then they're of type Fire. And so according to that lookup table, it does half as much damage, right? Ice fights fire, right? That was the first entry right here. Ice fights fire, and it's half as effective. So are we good on the setup? All right. We have been given some starter code here. First of all, here's the main, right? We read in Pokemon name 1, Pokemon name 2. We're given a couple of other files here. For example, we're given the names of all the types of all the Pokemon. Again, there are 18 of them. Bug, dark, all the way through water here. Otherwise, there are no other functions in this thing. And the H file is also empty. Obviously, we're probably going to want to define something to represent Pokemon. So let's go ahead and start there. All right? Tell me, what would you do to represent a Pokemon? If it's got an ID, a name, and a type. A structure. Type def. Struct. Right? And what should I call this structure? Pokemon? Okay. Right. Pretty straightforward. What will its values be? An ID. Right? A name, right? Char star name. And a type. Char star type. I'll just keep it as a string for now. Of course, you could go and the full 9 and you could define what else? An enumerated type to capture all those values. But I already put those values into an array of strings so that we can look them up if we want to. Okay? All right, that looks pretty good. Right. Now, what's the next thing that we're going to want to do? We're probably going to want to load up this grid here. Before we do that, let's go ahead and take stock of what we've been given. Right? These are all functions that have been done for you. A deep copy string function that takes one string and provides a deep copy of it. Of course, you could also, as an alternative, use what? strdupe, D-U-P, right? You can't use strcpy because that's that copies the contents of one string to another string, assuming that the memory has already been allocated for this thing over here. Right? This one allocates the memory for you and then copies the value over. We've also got this nice split utility. This utility function splits a string into an array of strings along the provided single character delimiter. Where could we use that? If I have a CSV file, what could you split it on to get each one of these 3 tokens? Comma. Right? If I had a non-CSV file, space delimited file here, what could I split on that to get these 3 tokens? a space. That seems useful, right? So split. Given a string that you want to, like a line in the file, a character delimiter that you want to split on, and I also have to tell you the number of tokens that I read, right? And that's what this pass by reference value is for. The last parameter is used to inform the calling function of how many tokens it found, and thus the size of the returned string array. Chomp removes any trailing white space from the end of the given string. Why would I want to do that? When I read a line of a file using, say, forgets, what's in it at the end? The new line character. Chomp might take that out for me. Cool. And then finally, free string array, a way to clean stuff up after I'm all done. Right? Let's just for a moment, let's take a look at the contents of that split function here. And let's walk through it as a reminder of some of the skills that we picked up before. You've done this before, right? You did it. You did split length, right, for hack 9 or 8 or whatever it was on strings. And the intention there was that you could use that on hack 10 to split up a DNA sequence into trigrams, right? But here it's a little bit different because we're splitting it up based on a delimiter. In other words, we're going to end up using strtoke, right? Str tokenization. I set this up, first of all, with a couple of counters. I create my delimiter string. Why did I need to do this? Why did I need to do a delimiter and then this thing right here? First of all, what is this thing? That's the null terminating character. What is the difference between a char and a char star? One is a single character, no null terminating character. The other one is a string that has to have a null terminating character here. All I'm doing is taking, say, your comma and then appending this null terminating character so that I have a delimit string here because that's what strtoke expects. Right? I chomp out. First of all, I make a deep copy of this because this is const. When I hand this off to strtoke, it's going to change the contents of that string. And I can't do that with the original string. I have to do that with a copy. Good thing I have that deep copy method, or the function that I already wrote. Right? Or as an alternative, what was it again? strdupe, duplication. What I'm doing here is I'm counting up the number of delimiters. So if it's a CSV file, I'm counting up the number of commas. Why? If there are 2 commas, how many tokens is that? 1, 2, 3. Right? And so I will count up the number of delimiters here. Why? So I can set up memory to hold each one of those tokens. Here's the result. I call strtoke to tokenize the first token. I keep a counter here. And then I go into a while loop. While that token is not null, I copy it into the result, the ith result, set myself up for the next iteration by tokenizing to the next token, incrementing my I. At the end, I make sure not to forget to free up that temporary copy of the string that I made up here. And I make sure to communicate to the calling function how many strings it should expect in this result. Right? Number of delimiters plus 1. Why? If there are 2 delimiters, then there were 1, 2, 3 tokens. So plus 1 gives me that last token. And then I return the result. Gee, that seems helpful. Maybe you want something like that. Right? And it's an early Christmas present. Give yourself something like this on the project. Right? Modify your split length to do something like this. Okay? Otherwise, there's the Pokemon data. There is the Poketype data. Let's go ahead and load up, as a first step, let's go ahead and load this up into a grid that kind of looks like this. All right, but they're going to be 0.5, 1, 2, in some cases, what else was there? 0.5, 1, 0. Is there a 0? 0. No effect at all. Oh, wow. This, like, ground goes to fly. I guess that makes sense. You can't reach them or something like that. Anyway, this is going to be a big giant grid holding all these numbers. Okay? Let's go ahead and write a function to do that for us. So let me go ahead and go over here to Pokemon H. And let's add a function to load up that file. So load grid. All right? And what should it return? What will that grid look like if I've got a bunch of numbers including 0, half, 1, and 2? A double grid. Double star star. Right? Why star star? Because it's two-dimensional. We can go ahead and pass in whatever we want here, but we'll figure that out later. Right? We probably don't need anything if it is going to be in this fixed file that's called Pokemon types.dat. Right? So let's go ahead and go over here to Pokemon.c, and let's implement this. Step 1. I've got to make the grid, right? So let's go ahead and allocate enough space for a two-dimensional array of how big. Luckily, I put that into a defined macro here. The number of types is 18. All you have to do is walk through this and count up all these types right here. Okay. So double star star result, or grid. Let's call it what it is. It's a grid. Right? Double star star. What do I call? Malloc. How many bytes do you want? Size of double star. Yep, just star here. Why? Each row is an array. So if you want to pointer to the first row, you need a double star. How many rows do you want? Well, 18, or what else could I do there instead? Use num types like I did up here. There we go. That way, I don't know if there are more types later on in Pokemon, are there? Does it go up from 18? It's still at 18? Okay, thank you. All right. 4, int I equals 0, I is less than num types I plus plus. What do I need to do now? I need to initialize each row. So the grid, the ith row of the grid should be a call to, again, double star malloc. Now how many bytes do you want? Size of, is it double star now? Nope. Right? You could probably get away with it because usually pointers are 8 bytes and doubles are 8 bytes, but you're rolling the dice then, right? Times, how many do you want? Oh, you want just one in the row? You want one row, yes, but you want 18 types in that row. So now you've got an 18 by 18 grid. Right? There we go. Now let's go ahead and go through and initialize these values as we're going along, right? So for int j is equal to 0. Actually, do we need to do this? Or I think we've got, how many combinations would we expect here? 18 by 18 would be how many entries? 18 times 18? 324, okay. And I see that they're all represented here. So we don't need to go through and initialize because even all the ones here will be found eventually, okay? All right, I've set up my grid. Ultimately, I'm going to return that grid. Now what do I need to do? I need to open the file. How do I do that? Open, right? And what am I going to be opening? Pokemon types.dat. Right? And I'm going to be opening it for what purpose? To read. Right? Now here would be another good opportunity. I don't have it here because it wasn't given to me, but again, Christmas, you can give yourself your own presents. Right? That's what you have to do when you're an adult. If you want a Christmas present, you got to buy it for yourself. Otherwise, you never get what you want. So, what kind of Christmas present would you give yourself? I would go back to hack 10, copy, paste, get lines, something like that, right? Reuse code that you've already developed. All right, so, but I don't have that luxury here. And besides, it's review, so let's go ahead and review how to do something like this. How do I read this file line by line? Well, first of all, I'm going to want a line pointer to know when I'm done because I'm going to be using forgets, which gets an entire line. And when I'm at the end of the file, what's going to happen? It's going to return null, right? So while the line is not equal to null, I will read the next line and process it, et cetera, et cetera. What else do I need? A buffer. In fact, I'm going to call it buffer. How big? Oh, 100 is big enough, right? All you need to do is look at the longest line here and say, oh, okay, well, you could get away with something like 23 or 24 or something. Just go ahead and make it big. Right? You're not wasting space here because this is a static array. It is allocated on the stack, And when you return back from this function, it'll be popped off the stack and cleaned up for you. Don't worry about it. Okay? How do I get that first line? If it gets to the buffer, a limit of 100 minus 1 for the null terminating character, it takes care of that for you, reading from file F. Right? And what else do I need to do? If it gets returns a value, right? Need to capture that value. Okay? Now, while I've read a line, etc., I need to process the line, ... then read the next line, ... Let's take care of the easy one first. That's going to be exactly what I did up here. Copy, paste. All right. Okay. How do I go about processing that line? Let's just look at one line here. This line would be one possible value stored in that buffer. What do I need to do? I need to split it on these spaces to get the first one, the second one, and then the actual value here. So was there a function to do that for me? What was it called? Split, right? I wonder, how did that work? Well, we already looked at it, but here's the signature. You provide it the string that you want to split up, the delimiter along which you want to split, and then also a value, a pass by reference value here, pass by reference variable, I should say, as a sanity check to make sure that you got 3 tokens. Right? So let's come back over here, and I'll go ahead and create that num tokens. Right? That's my integer, and I will call split on the current line or buffer. Line buffer would be the same thing at this point, and whatever's stored in that buffer. The delimiter along which you want to split it, which in this case is going to be a space. Okay. And then finally, what? Num tokens. Is that how I pass in num tokens, though? Nope. It's a regular old integer. So how do I take a regular old integer and make it into a pointer? Ampersand. Good. It returns, I don't know, char star tokens. Right? Right. You can go ahead and check, do a sanity check here. Sanity check. Right. If num tokens is not equal to 3, we've got a problem, right? So printf error some %d tokens found for some reason, ... And the line, you can quit, or you could just, in this case, we'll just go ahead and print this out. That's not going to happen, right? Num tokens. But if you wanted to, you could go ahead and quit here at this point, okay? Otherwise, I've got tokens of 0, which is the first Pokemon, first type, right? Tokens of 1, which is the second type. And then finally, I've got the multiplier, which is tokens of 2, right? Is tokens of 2 a double? It's a string, so how do I take a string and convert it into a double? How do I take that 1.00 and turn it into a double? ATOI would be integers. ATOF, can't get that out, would be for floating point numbers, doubles. Okay. All right, well, what do I do with this? Just given a type, a first type and a second type, I want to find the row and the column that corresponds to. Let's go back over here to Pokemon, up here, right? I put all the types into an array of strings here. So that if it's a bug type, that'll be at index 0. If it's a water type, that'll be at index 17, the last one, because there are 18. But I don't see any way here of taking a string, the representation being either electric, ghost, whatever, and converting that to an integer that represents the index of this array. So again, what should we do? That sounds like a present that we should give to ourselves. So let's go ahead and make that function. Here we go. Oops, didn't want to do that. All right. So we'll say type to index, right? And it'll take a const char star s, or type, let's call it, because that's what it is. And it'll return an index. And by the way, we should be documenting this entire thing along the way. All right. So what does this do? This function takes a Pokemon type, such as bug, or give me another one, fire. All right, let's go with that. And returns an index corresponding to the type array. All right. Okay. Why is that going to be useful? Because then we can use that in our grid. If we've got, what were the lists again? If we've got bug, dark, dragon, electric, right? Then it's going to be bug, dark, dragon, electric. And then we can look up the attacking Pokemon, the defending Pokemon type, and then we can jump to that position right there. So before we even write that, let's come back over here to what we were doing. And let's assume that that's been given to us. Somebody else wrote that. Right? I'm going to have to write that here in a second. That would give us the index of the first one. What did I call it? Type to index. There we go. And type to index of the second one. Let's finish this out before we actually have to implement that thing. Okay? Once I've got the first index and the second index, I've got the number that should go in the grid. So place it in the grid. Grid of index A, index B is equal to multiplier. There we go. Good? Okay. Now, let's come back over here and actually implement this thing. To do that, I'm going to go ahead and go above this. What would that look like? Let's just do a straightforward implementation for this. All right? You've got the needle, the type. You've got the haystack, Pokemon types. What do? Go through the haystack looking for the needle. Well, what did we call that kind of searching? You start at the beginning. Is that it? So I've got a type in my hand right now. That's not it. That's not it. That's not it. Oh, that's it. Fine. That would be sorting. What am I doing? I'm searching through the haystack for a needle. This is linear search. Right? So for int I equals 0, I is less than the num types, I think it was. Yeah, num types. I plus plus. If, what did I call my array? Pokemon types of I is equal to the type, then return I. This is a string. This is a string. Is this how we compare strings? Nope. How do we compare strings? strcmp. Right? And if those two things are the same thing, then I return I, the index at which I found it. What do I compare it with? Say what? 0, right? It's a comparator. It returns something negative, 0 if they're the same thing, or something positive if they're out of order. What's an by the way, so if I don't find it, then something seriously went wrong. I can print an error message here, or I can simply return. What did we do in class when we did this? Returned a negative index, right? That's definitely an invalid index. This is a basic linear search algorithm. Can somebody suggest an alternative? bsearch, right? And good thing I already put them in alphabetical order. I didn't put them in the order that gave me here. Normal, fire, water. I have no idea what order this corresponds to in the game or anything. It's not in alphabetical order. It's not in lexicographic order. But I chose to do mine in lexicographic order so that you could do bsearch if you really wanted to. Right? What would that look like? It'd be kind of iffy because you would search through for a particular string. First of all, you'd have to make a comparator for strings. And at that point, you're going to have to reference the book, my book, because I don't think it's in Zybooks, on how to do that for strings, because it requires some doing. This is why we didn't even expect this, right? We expected some brute force solution, but this is a good one, right? Okay, that all looks good so far. Let me go ahead and compile all this stuff, and just to make sure that I have no. Oh, darn it. A2F, printf. So what should I have been including this entire time? String library is there, stdio. What else? Standard library, stdlib. Okay. What else do you want? Split. Okay, I should have included what? The utils.h. There we go. All right, now I've got all my includes there. Okay. Let's make sure that this actually works. I'm going to go over to the main here, and I'm going to double grid, star grid equals load grid. There we go. Let's just go ahead and make sure that this works by printing it out. For int I equals, actually, I don't want to print out the entire thing because that's just going to be one big giant grid, and it's not going to make much sense. So let's just take two examples or one example and just do a quick sanity check here, right? So int index I is equal to, what is it? Type to index. Give me your favorite Pokemon type. Fire. Okay. And int j is equal to type to index. Somebody else give me their favorite Pokemon type. Ice. Okay. Oops. There you go. So printf fire to ice should be %f and the line grid of I j. There we go. And when fire fights ice, what should happen? Is that in the handout? All right, that ice fights fire. So what should it be here? Oops. Hey, forget and ignore that for now. 2. Is that correct? All right. I'll trust you. All right. We've got somebody that says that's correct. Okay. I'm 90% confident in whether the stuff that we just wrote. Okay. What did we say? Fire fights ice. Oh, of course it would be super effective. It would melt it, right? Yeah. Okay. All right. Okay. Although once it's melted, then it's water, so I don't know. It puts it out. All right. Anyway. All right, next. We've got our grid. We don't have our Pokemon yet, do we? So let's create another function here to not just load the grid, but load the Pokemon. Now, those aren't going to be doubles. What are they going to be? Pokemon. Now, are you returning 1? Nope, you're returning an array. And I think that there are only 100, I think, what was there? 100 and some, 151, exactly 151. So maybe we can go over here and hard code that as well. The number of types is 18. Why not just go ahead and define the num Pokemon as, what did I say, 151? All right. I'm good with that. All right. Kind of the same thing, but a little bit different here now. Help me out. What should I do first? Well, before I even load the file, what should I do? I don't have any parameters here whatsoever. I could have given you the file name and made this a little bit more general, but we ended up hard coding the file name up here, so we might as well do the same thing down there. What did I do up here? I allocated memory for each one of those things. So Pokemon, right? Result or whatever you want, Pokemon equals Pokemon star call to malloc. How many bytes do you want here? Size of, now not size of int, not size of double. You are creating what? Pokemon or Pokemon, whatever it is. Right? Whatever the plural is. Right? And what did I say? Num Pokemon? Pokemon. Come on. There we go. All right. All right. And then I need to open up the file. F equals. By the way, did I close it up here? Naughty. I didn't. I should have. For close, F. Oops. There we go. Not that it would have caused that major of an issue, but same. In fact, I'm going to go ahead and commit another sin here and copy pasta. Probably shouldn't be doing this, but we'll go over line by line here to make sure that it's correct. Pokemon.dat. Was that the file name? Pokemon.csv. Right? This is where you get yourself into trouble with copy pasta. You change one thing, but not all the things that you need to change. Whereas if you typed it from scratch, then you have a little bit better assurance that everything is correct. This is still okay. This is still okay. This is still okay. Right? Now wait a second. I'm going to be reading 151 Pokemon exactly. So if I continue after reading 151 Pokemon, what's going to happen? What if I read all the way to line 162? Are there any Pokemon to read? No. I'm going to get myself into trouble. And a lot of people have gotten themselves into trouble on their projects by not respecting that first line. In this case, there's not a first line to tell you that there are 151 Pokemon. There is a handout to tell you that. Okay? So let's go back over here and not do a while loop. What's more appropriate here? A for loop. For int I equals 0. I is less than num Pokemon I plus plus. Okay? Now I've already read the line in at this point, so I need to process it. Process the current line, current line, Now, read the next line. And how do I read the next line? That's exactly like this. Okay. Good. At the end, I for close and return Pokemon. There we go. Good. Now I need to process the current line. How did I do that before? Well, let's remind ourselves what it looks like here. So it'll be an integer with leading zeros, who cares? And the name of the Pokemon, and then a string representing its type. So I'm probably going to want something very similar to what I had before, with exactly 3 tokens. Right? This way, this time I won't bother with the sanity check. Right? Except am I splitting along spaces now? I'm splitting along what? Commas. So the first token, tokens sub 0 is the ID. Right? Tokens sub 1 is the name. And tokens sub 2 is the type. All right. How do I go about setting up the ith Pokemon? I want to initialize the ith Pokemon, which is stored in Pokemon sub I. Ideas? What would you do to make your job easier? Put it in a function. Right? What would that function look like? It would look like any function that you've written up to this point. Init RSS, init airport, init transaction. Hopefully you've been doing that. Init whatever else we've done. Init film like we did in class. Init student like an example in your lab. Right? What would it look like? Void init Pokemon. What does it take? An int ID, a const char star name, a const char star type. Okay. Let's document to do. Yeah.
Can you put const on like ints and doubles and all that?
You can. The only difference is that it can't. Then that means that inside the function you can't change ID to be 2, right? Well, who cares? It's your. I gave it to you. I passed it by value, so you can't change my stuff. So I don't care if you change your stuff or not. But if you have an intention that even inside this function, I want to make sure that I do not change this, and I don't trust myself not to change it, then you could put in const. Right? So it all depends on how much you trust yourself. All right. Let's come back up. I'm going to come up here and put it at the top. What would that look like? I don't see a Pokemon to initialize, do you? Okay. Remember there were two types of initialization functions. One was like, say, create airport, where it created a brand new airport and gave you a pointer to that dynamically created airport. The other one was, give me an airport that's already been allocated, and I will go ahead and set its ID, its name, its latitude, longitude, or whatever. Right? I've chosen to do the second design here. So what do I need to give? A Pokemon star P, and I'll just call it P in this case. Right? Why a pointer? Well, because I need to make changes to it, right? If I didn't you could do something like this. That copies all the values of that structure onto the stack. You can change them all you want. Who cares? At the end of the day, when the stack frame gets popped off, they're gone. Right? By passing it by reference, now I can make changes to the original structure. All right, let's implement this, and then we'll use it down below. In fact, we're going to have to change the signature over here. Right? There we go. Fixed. Oh, here, going back to your question of const, could I do that? I could, but then are you going to be able to make changes to it? Nope. All right. It's a little bit different with this particular case, but don't worry about it. Okay. Return at the end. So I want to copy over the ID. P's ID. Right? Remember, here's what it is, ID. Right? P's ID. How do I get that? Dot ID is equal to ID? Arrow. Why arrow? Because I've got a pointer to it. Right? If I had a regular old structure, then it would be the dot operator. This is the indirect component selection operator that relieves me of the need of dereferencing it in parentheses, then using the dot operator and getting all messy. Okay. All right. How do I copy over the name? Is that correct? You could do that, and you might get away with it in this case, but probably not a good idea. What kind of copy is this? It's copying a reference, right? So these two things are pointing to the same thing. We called that a shallow copy. What I want is whatever the name is, Jojo over here, and then Jojo over here, right? I want them. I want a completely different copy. That's called what's the opposite of shallow? Deep copy. How do I achieve that? I gave you a function to do that. Or alternatively, what was the alternative? strdupe of p of name. There we go. Good. And p type is equal to strdupe of type. Excellent. Yeah. Yep. It is not part of the C standard library. I think it's a GNU extension. Man, strdupe. Read all about it at your local man pages library. Yep. What was it? Let's see. It's POSIX. It might be POSIX. I'm not sure. It looks like a GNU extension to me, though. Right. If you had a really, really old bare bones version of C, or wanted to compile for like an older system, you probably wouldn't have the luxury of this thing. But you can always write it. Yeah.
So why'd you create a function for it when you could just use string duplicate like you did?
Probably because this was 3-4 years ago. Whatever we were using at the time, probably on CSE at the time, they didn't have strdupe. Okay. It might have even been ANSI C by default. Okay. Besides 6 of one, half a dozen of another. All right. Where were we? There we go. So we want to initialize the ith Pokemon. Init Pokemon, and I want the Pokemon of I, and I want to initialize an ID, which would be a to I of tokens sub 0. Tokens of 1 is going to be the name, and tokens of 2 is going to be the type. And I don't need those anymore. Or I can just go ahead and comment that out. Right. Don't leave dead code in your final submission. Right. I'm just writing this stuff as a guide here. Okay. Now, is this the correct way of passing in the ith Pokemon? Pokemon itself is a Pokemon star. When I index it like this, I get an actual Pokemon structure, a regular old structure. Init Pokemon expects a pointer to that structure. So how do I take a regular old structure and make it into a pointer? Ampersand. Okay, good. Now let's go back to main and let's load up our Pokemon. Pokemon, or men, whatever, is equal to load Pokemon. Let's make sure that it actually compiles first of all. Darn it. Nope, just unused. Apparently I didn't use line in the other one, so go back, take that out. You do get generally docked for not addressing warnings, so I'll go ahead and take care of that. The other two warnings, of course, I haven't done anything yet with them, right? So for int I equals 0, I is less than num Pokemon. If we want a sanity check here, we can go ahead and print these out. Printf %d, %s, and the line Pokemon of I. Now in here, do I use the dot operator or the arrow operator to get its ID? Careful. Pokemon is a Pokemon star, but Pokemon I is a regular old structure. When I've got a regular old structure, it'll be dot. Pokemon of I dot name. Pokemon of I dot type. All right. Oh, well, I did use it. What are you talking about? Oh, I used it right there. All right. Yeah, all right, fine. Ignore that warning.
If you temporarily pass it in as like a pointer, you could use the arrow, right?
Yes, you could. If you wanted to go whole hog here, you could write a Pokemon to string function, right? Returned a char star version of, just like airport and everything else that you've done up to this point. This is just a sanity check, though. I just want to make sure that this actually works. Right? Oops. A, B. Right? Oh, darn it. It's not. Remove a dot out. GCC. Okay, I actually got an error in here. Oh, here we go. Oh. Duh. I++. Was that all? Oh, num Pokemon. Oh. No, it was up there, wasn't it? Oh, I put it in .c, it looks like. All right, fine. You know what? Let's go ahead and move both of those to Pokemon.h because that's where they should be anyway. And now, yeah, you compiled now. Great. All right. Now, when I do this, it should just list out all the Pokemon because I haven't done anything with it yet. So it is 151 Mew Psychic. I don't know. Let's check the file. I was asking you. Mew Psychic, and all the way up to 1 was what? Bulbasaur grass. Hey, looks like it works to me. Excellent. So let's go ahead and get rid of this sanity check. I've loaded up both of those files successfully. All I have to do now is take this name, which is stored in argv sub 1. Right? That's the first Pokemon. And the second Pokemon is in argv sub 2, name of second, and name of first. I need to find those Pokemon, and then I need to find their type, and then I can look those types up in their grid. So, first one, find the Pokemon structures with names, ... Ideas? I could do what I did before and implement a linear search and just go through, I'm looking for Charizard. Bulbasaur, that ain't it. Ivysaur, that's not it. 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 Oh, there it is. Found it. And their type is fire. Great. I've got the first one. Do that again for the second one. Once you've got the types, then it's an index lookup. What's an alternative? So that incorporates what we've been looking at very, very recently, that you will have to utilize for your project. Searching and sorting. Okay. I'm going to be wanting to search for a Pokemon by their name. So maybe what should I do? A binary search, but before I do a binary search, I can write my own binary search. I don't want to do that. Right? How do you say, this Pokemon is equal to this Pokemon or not? Oh, sorry, there, comparator, right? So let's make a comparator based on name. Int, CMP Pokemon by name. And so do I take two Pokemon, A and Pokemon B? Nope. That's not a comparator. All right. Do I take them by reference instead? That's a little bit closer. But is that a comparator? Nope. All right, because I'm not going to be making changes to it. So maybe they're consts. Is that it? Nope. Last try. Void. Comparators are always const void stars. Right? Because there is only one generic type. All right, take that, save it, bring it over here. What's the first thing I do in my comparator? Typecast. So I do need a Pokemon. I'll call it P and Q. P, and then the next one is Q. Right? Is equal to const Pokemon star of A, and Q. I could do P1 and P2 if you want to. Otherwise, yeah, 1, 2 of B. There we go. Now, how do I compare these two Pokemon by their name? strcmp does that for me, right? P1, their name. P2, their name. That'll return something negative, something positive, or 0, depending on the relative ordering. Do I need to do anything special with that value? Nope. Just simply return it, like you've been doing with airports, and students, and films, and right now transactions, hopefully. Okay. Now that I've got my comparator here, how do I go about searching for it using bsearch? Can I just use bsearch immediately? Nope. What do I need to do in order to use bsearch? You need to sort it first. Qsort is what we use for that. How do you call Qsort again? Consult your local library. Man, Qsort. All right. The thing that you want to sort. Well, what do you want to sort? You want to sort the Pokemon. Okay. How many things are in there? 151 Pokemon, or that num Pokemon. How many bytes does each one take? Size of Pokemon. And finally, the comparator that you want to sort it with respect to, which was what again? Pokemon, CMP Pokemon by name. Now, once I've done that, I have a very, very different order than what was loaded up in the file here. What would end up coming first? Arbok, maybe? Is there any others that start with A? What? 65. Thank you. There. Is that the first one? Maybe. Who? AB, there we go. Is there any aardvark? I don't know. Nope. Anyway. So, it's been sorted according to the names. How can I then now find the first Pokemon based on their name? ... bsearch is exactly the same call, except for what? I need a key. So is argv of 1 my key? You're searching an array of Pokemon. Argv of 1 is a what? A string. Are those two types the same thing? No, you're searching for an apple in a barrel of oranges, or you're searching for an orange in a barrel of apples. It's not going to work. So ideas, how do I make a key? Pokemon, key 1, right? And I can use this, the syntax that you used in lab 13. I forget the numbers, I think it's lab 13, where you can create an ID, I don't know, 0. I don't care what the ID is. The name, in this case, it's going to be argvis of 1. And then finally, the type, we'll just go ahead and make that into an empty one. Or you could go ahead and use your init function to do it for you, which is actually probably safer. Init Pokemon key 1, and I will initialize it to 0 for the ID, an empty string for the type, and then whatever name you gave me for that. Right. There we go. And now I can go ahead and pass in this key 1. Is that how I pass it in though? It requires a what again? Man bsearch. It requires a pointer. So how do I take a regular old structure and make it into a pointer? Ampersand yet again. And this actually returns something. Qsort doesn't return anything because it's just taking the array and modifying it. bsearch is searching through the array and gives you back a pointer to that needle in the haystack if it finds it. So Pokemon attacking is equal to this. And of course I need to make it into a pointer. There's the attacking Pokemon. Do the same thing again for the second Pokemon. What's the only difference? First of all, I need a second key. And the second name. Right? And defending. There we go. Now, let's just make sure that we are actually finding these Pokemon. So, printf. %s, and then this. I think in a handout we said print it out like this: their name, their type, attacks, name, type, and then does whatever damage. So their name, type, which is also a string, attacks, name, type, ... We'll come back and finish the rest of it after we're assured that this works at least. So attacking. And now, do I use the dot operator here or do I use the arrow operator for to get their name? Arrow. Why? Because attacking is now a pointer. Okay. Attacking type. Spell it correctly. There we go. Defending name and defending type. Okay. Make sure that it works. Oh, okay, fine. I'll behave. So it's complaining here. Why is it complaining? Because these are const, meaning I made the promise that, on my honor, I'm not going to make changes to this thing, right? Well, okay, but then you cast it to something that you can make changes to. Warning, it looks like you're breaking your promise. But if I put a const here and a const here, then those warnings go away. I'm still getting a warning here because of unused things. And oh, by the way, I'm getting I forgot my semicolon apparently. Yeah, there we go. Otherwise, I'm just going to get warnings. All right. Again, we'll take care of these in a moment. Okay. Let's go ahead and run this. If I give two invalid Pokemon, oh, first of all, if I don't give any arguments here, then obviously it's going to error out. But if I give a, I don't know, Godzilla and Mothra, right? Are those real Pokemon? Are Pokemon real? No. Segmentation fault. Why? Because it can't find those. How could I have handled that a little bit more gracefully? Some error checking here, right? If attacking, what happens with bsearch if it didn't find what you were looking for? It returns null. Right? So printf unable to find %s and the line. what is it? Argv sub 1. Same thing for defending. Unable to find argv sub 2. Oops. And so now when I do this with Godzilla and unable to find Godzilla, unable to find Mothra, maybe I quit then instead, right? But otherwise I'm going on and trying to do stuff with it. That's not going to happen. So you could go ahead and quit here if you really wanted to. How do I quit prematurely? Exit with maybe an error code of 1. Invalid Pokemon A. Invalid Pokemon B. Right? Something like that. And now I won't get a segmentation fault here. In fact, I'll get that Godzilla is unable to find that. So give me an actual Pokemon to fix this. M-E-W. Like that? Yep. All right, the number 2. All right, it's able to find Mewtwo, but it's not able to find, defending. Oh, what did I screw up? Copy pasta again. Key 2. It found what happens, is that possible? The same thing can attack the same thing? Yeah. All right, fine. All right, there we go. Unable to find Mothra. All right, fine. We'll do Mewtwo and Mewtwo. They fight each other, and they have some multiplier or something like that. All right. I'm convinced that it's good up to this point. Now, the final step is find the multiplier. Thank you. You already pointed, you pointed that out online, too. I was using the same key. Thank you. All right, so I need to find on that grid. Well, how did we find on that grid before? Index A is equal to, what was it, type to index of attacking type. Right? And index B should be the same thing, but defending type. And then you can make another check here to make sure that those are not -1, right? And otherwise, I'm just going to go ahead and say that the multiplier, double multiplier, is equal to the grid of index A, index A and index B. Good. And so I'll print that out. Does %F damage? And I'll print out the multiplier. So tell me what happens when a Mewtwo fights a Mewtwo. Really? Okay. Oops. I didn't, multiplier. Oh, multiplier. Fine. That's still wrong. Index B is undeclared. Fine. Int. There we go. All right, good. And all the warnings now go away except for this 1 in that other function, which we'll take care of here in a second. Load Pokemon. You said 1? Oh, 0.5. Is it? So Psychic goes to Psychic. Looks like 1/2 to me, too. This is official. This is the reality of it. All right, what? Give me another one. Charizard is the only one I know. I guess the Bulbasaur. Okay. What should it be? Fire to grass. Fire burns grass, right? So it should be 2, right? Fire goes to grass. Yep, 2 right here. I'm convinced that it works. Throw it on the grader, find out. Gendar?
Gengar.
Well, I was going to try one of the zeros because we 0.5 and 2.
You're going to have to help me. Who? Like EV? Like that? I only know that because my daughter doesn't watch this. She's only 5 years old, but that's her present for Christmas. Anyway, EV and what?
Gengar,
D-E-N? G-E-N? Gengar. Okay, thank you. That should be 0. All right. Yay. Is normal. Are any of these things normal?
Normal versus normal.
All right, so Some tips that I would give you here are, go back and clean it up. Of course, you need to document everything, et cetera, et cetera. We do only have about 10 minutes here, but I don't think that we can get this done in 10 minutes, but, I think I read it. So this is Advent of Code. This is day 1. If you've done it already, great. But I'll walk you through it next time, maybe. The only other tips that I want to give you, with respect to your final and your project, are, especially with the project, look for searching and sorting solutions. For example, some people have already started on the duplicates report, right? So the duplicates report, first of all, is only on that first file. You've got 10 million records. I'll start at the first record and check all the other 10 million to see if that's a duplicate. Right? Okay, I found duplicates here and here. Great, report those. Now go to the second one. Look at all the other ones, all the other 9,999,999 of them, and see, okay, there's a duplicate there and a duplicate there. Report those. Proceed as follows. Is that going to work for 10 million records? 10 million times 10 million is how many? A lot. 100 trillion or something like that? I don't know. Right? Is that going to execute in the 5 minutes that you have on the web grader? Nope. You're good if you'd be excellent if that would execute within a week or two, right? So you're going to have to look for better solutions. Think of this in terms of, say, simple numbers. If I've got a bunch of numbers and I sorted them, where would all the duplicates be? Right next to each other. If I have 1, 2, 3, 4, 5, 5, 5, 5, 5, guess what? There's all the 5s. If I sort all the transactions, where are all the duplicates going to be? Cluster, not here's one and then here's one a half a million away, here's one 5 million away, right? Instead, all 3 of those duplicates are going to be where? Right next to each other. Do I have to go through every single combination? No, I just have to go through it once. Right? And these 3 are duplicates. Not a duplicate, not a duplicate, not a duplicate. These 4 are duplicates. Not a duplicate, not a duplicate. Just go through it once. That's going to be even, that solution is not necessarily going to work for the last report, but you do have to do something similar, right? If you've got 10 million and 10 million, and you want to verify that this record, I found the record over here, but they disagree in like $5. That's suspect because somebody probably changed the database snapshot. Are you going to be able to do that if for each record over here, the 10 million records that you have over here, you're checking all 10 million over here? Probably not. You're going to want to look for an efficient searching and sorting approach to it. Right? Use the built-in searching and sorting algorithms. Use qsort. Use bsearch. If you didn't do that in your hack 13 or whatever it was, go back and review that. Go back and review the lab 13. And above all, what you finally hand in for the project, make sure it works. If you don't get to that last report, at least hand in what you have and make sure that it compiles and make sure that it runs. Right? If it's buggy, comment it out. You can leave it in there if you want, and we'll take a look and say, oh, well, here was the problem. But at least the other ones work, and you'll still get points for them. If you hand in something that doesn't compile or just seg faults out entirely, there's not much we can grade. So hand in what is actually working, okay? And that's very, very easy if you separate them all out into different functions. Then you don't have to comment out the entire function. You just have to comment out your call to that function. Questions? No? All right, then we'll do some more, we'll do Advent of Code next time on Wednesday.